Hey guys, and welcome to this video on AVL trees. So an AVL tree is just a self-balancing binary search tree. And in this video, we want to create an AVL tree by inserting the following values, which I have in blue here, into our AVL tree. So the values are 45, 70, 35, 3, 74, 25, 81, and 60. So let's go ahead and get started. First thing we're going to do is insert the value 45 into our tree because our tree is empty. So that's the first value. That's our root node. Now 45 has a balance factor of 0. And if you're not sure what a balance factor is, a balance factor is the right subtree minus the left subtree. And if that value is within the set -1, 0, or 1, or if it's equal to any of those three values, then the tree is balanced. And how you check that again is you check the right subtree minus the left subtree. So currently the right subtree of 45 is null, and the left subtree is also null. So our value is 0 because we get the right subtree, which is 0, minus the left subtree, which is 0. Okay. So let's go ahead and erase this. Now, let's insert the value 70 into the tree. So 70 is greater than 45. So 70 is going to go to the right of the tree, of the node, 45. So we place 70 again to the right of 45, and we need to check our balance factors again. So 70 has a balance factor 0 because the left subtree is null and the right subtree is null. So we get 0 minus 0, which equals 0. Now, what's the balance factor for 45? So let's erase the old balance factor and calculate the new one. Well, the left subtree of 45 is null, and the right subtree is 1. So we get 1 minus 0, which equals 1. Okay, so both of these values are still within that set. So this tree is still considered balanced. All right, so now let's erase our balance factors here. Okay, and erase our null values. Okay, so next we need to insert the value 35. So 35 is less than 45, so it's going to go to the left of our node 45 here. And so reinsert the value 35. Now, is our tree still balanced? Yes. So let's take a look at the balance factors. So 35 is balanced because the left and right subtree are both null, so we get a balance factor of 0. 70 is still balanced because its left and right subtrees are null, so we get a balance factor of 0. 45 is balanced because the right subtree is 1 and the left subtree is 1, so we get 1 minus 1, which equals 0. So this is balanced. Okay. And I'm just going to go back and erase these balance factors. Okay. So now let's insert the value 3 into our tree. So 3 is less than 45, so we go to the left of the tree and we get to 35, and 35 is greater than 3, so that means that 3 is less than 35, so 3 is going to go to the left of 35, and there we insert the value 3. And we need to check our balance factors again. So we know that 70 still has a balance factor of 0 because nothing has changed on that side. Nothing has changed for that node. We know that 3 has a balance factor of 0. And that's also because its left and right subtrees are null, just like the node 70. 35 has a balance factor of 0 because its right subtree is null, minus 1 is left subtree. So that gives a value of -1. So it's still considered balanced. And then 45 has a balance factor of 1 minus 2, which gives us -1. So its balance factor is good as well. So the tree is still balanced. So let's go ahead and erase these balance factors. So this is good. That means that we haven't had to do any type of rotations yet. Okay, so next we need to insert the value 74 into our tree. Now 74 is greater than 45, so it's going to go to the right of 45. 74 is greater than 70, so it's going to go to the right of 70. And there we insert our value 74. Okay. Now we need to check again the balance factor of our tree. So 74 has a balance factor of 0 and 3 has a balance factor of 0 because both of their subtrees are null. 35 has a balance factor of 0, its left subtree, minus, 0 is its right subtree, minus 1, which is its left subtree. So we get a balance factor of -1. 70 has a balance factor of 1 minus 0. So that's its right subtree minus the left subtree. So it gets 1. So it's still balanced. And then 45 gets a balance factor of 1, 2. 2 for its right side minus 2 on its left. So it gets a balance factor of 0. So our tree is still balanced. So let's go ahead and erase these balance factors. Okay. All right, so now we need to insert the value 25 into our tree. So 25 is less than 45, so it goes to the left of 45. 25 is less than 35, so it goes to the left of 35. And 25 is greater than 3, so it's going to go to the right of the value 3. So we insert the value 25. Now let's check our balance factor. 25 has a balance factor of 0. 74 has a balance factor of 0. 3 has a balance factor of 1 minus 0 because its left subtree, it doesn't contain any values in its left subtree, and it contains a right subtree. So we do 1 minus 0, which gives us 1. 70, its balance factor is 1 minus 0, which gives us 1. 35 has a balance factor of, let's see, 0 minus 2, so we get -2. And -2 is not within our set, so this tells us that at this point of the tree is unbalanced. And if we look at 45, we get 2 minus 3, which gives us -1. Okay, so 45 seems to be okay. So we need to take a look at this subtree here, and we need to do what's called a left-right rotation. So let's rewrite, well, first let me get rid of that box I just created, and let's rewrite that subtree. So we get 35, 3, 25. Okay, So let's do a left rotation. So we get 35, 25, and then 3. And then to do a right rotation, we get 25, 35, and 3. Okay, so now let's replace that subtree with this new balanced subtree. All right, so now we're going to get 25, 3, and 35. And I'm going to erase this work that we just did down here, and I'm going to erase the balance factors here. Okay, all right, so we just now got done inserting the value 25. So now let's insert the value 81. So 81 is greater than 45, so we go to the right of 45. And 81 is greater than 70, so we go to the right of 70. And 81 is greater than 74, so we go to the right of 74 and insert the value 81. Now let's check our balance factors. 81 has a balance factor of 0. 74 has a balance factor of 1 minus 0, which gives us 1. Let's see, 70 has a balance factor of 2 minus 0, which gives us the value 2. And 2 is not within our set saying that the tree is balanced. So I'm going to put a little star there. Now 3, all the way over here to the left, has a balance factor of 0. And 35 has a balance factor of 0. 25 has a balance factor of 1 minus 1, which gives us 0. And 45 has a balance factor of 3 minus 2, which gives us 1. So it's balanced. So here we have our unbalanced subtree. All right, so let's make it balanced. I'm going to rewrite it down here. 70, 74, 81. What we need to do here is a left rotation. So this just simply becomes 74, 70, 81. All right, so let's write or rewrite our subtree here and get rid of the balance factors. Okay, and there we go. All right, so now we get 74, 70, and 81. All right, so now our tree is balanced. Now, next we need to insert the value 60 into our tree. So we get 60 is greater than 45, so we go to the right of 45. 60 is less than 74, so we go to the left of 74. And 60 is less than 70, so we put 60 to the left of 70. Now let's check the balance factors of the tree. Okay, so 60 gives us a balance factor of 0. 81 gives us a balance factor of 0. 3 gives us a balance factor of 0. And 35, 0. 25 gives us 1 minus 1, which equals 0. And 70 gives us 0 minus 1, which gives us negative 1. 74 gives us 1 minus 2, which gives us negative 1. And 45 gives us, 1, 2, 3 minus 2, which is 1. So our tree is completely balanced. All right. So thank you guys. I hope you enjoyed this video. I hope I explained it well. Please let me know